What we're going to talk about today are things that can cause climate change that occur naturally as part of our Earth's natural processes. You should have already read section 14.3 by this point, and so the notes that we're going to go over today are helping you to take that information and organize it and put it all in one place so that when you're studying for the quiz, you've got a quick reference chart as far as what different things can cause climate change and what sort of categories they fall into. You should have a blank piece of paper in front of you. I always turn mine landscape, and that's just because of the way my board is oriented. It's longer in length than it is in height. And we're just going to make this kind of like a flow chart or like a concept map sort of notes. So we're talking about natural climate change, and I put my title at top center. First, we're going to talk about the climate change causes that are short-term or mostly short-term climate changers. So off to the left, we will put short-term climate change. Move this box out of the way. Now, when we say short term, it could be in terms of a single year or a couple of years. It could be like 10 or 12 years. Things that are short term take place in 1 to maybe 10 to 15 years. One of the most obvious things that is a cause for short-term climate change is something that we deal with all the time here in the Midwest, and that would be simply the change in the seasons. Changing seasons fall under short-term climate change. What we'll learn about a little bit in more detail in the next chapter, chapter 27, is what causes the seasons. But for today, we really just need to know that these are caused by the tilt of the Earth's axis. Whether our hemisphere, we are in the northern hemisphere, is tilted towards the sun or away from the sun, or neither. The seasons are caused by the tilt of the Earth's axis. A second thing that can cause short-term climate change would be volcanic activity. And I'm trying to save some space here. Hopefully you have more space on your page, but I'm going to put this one right underneath seasons. Volcanic activity. Volcanic activity can change the climate by having an eruption from a volcano that is mostly dust or ash. And again, this is something we'll learn more about. This will be during second semester. Different kinds of volcanic eruptions can produce different kinds of things. Some of them produce lava, like what you expect in Hawaii. Some of them produce mostly dust and ash. This would be kind of like the Mount St. Helens eruption in 1981. But this dust and ash that gets erupted into the atmosphere has the ability, if there's enough of it, to block the sun. Not entirely, of course, but it can decrease the amount of heat that we get from the sun. And if it decreases it enough, then that can change our climate just a little bit and make it colder. One of the examples that your book talks about was the eruption of Mount Pinatubo in the Philippines in 1991. And it resulted in slightly cooler temperatures around the world for the following year. So again, this is short term. The volcano might erupt, the dust would block the sun for a little bit, eventually that dust would settle out of the atmosphere and our climate would return to its previous state. We have two more things that can cause short-term climate change. One of them is something that's being talked about in the news, right now, and that is El Nino. This is an El Nino year. El Nino in Spanish means the baby, and historically I believe this name comes from the idea or the suspicion that this particular climate change was associated with the year of, according to the Christian religion, Jesus's birth. But for us, we are just mostly concerned with what does that actually cause in terms of climate change. El Nino occurs when you have a reverse in ocean currents between Australia and South America. And there's a couple of really good pictures of this in your book on page 389. Normally, the ocean current from South America to Australia flows west. So it pulls cool water kind of from Antarctica up the coast of South America, and it pulls that west with the trade winds towards Australia, and that water warms as it travels through the area of the tropics, and it brings warm water to Australia. During an El Nino year, though, that current, for reasons that we don't completely understand, that current reverses itself. And so instead of bringing cool water from Antarctica over to Australia, it takes Australia's warmer water and brings it back in our direction towards South America. So El Nino causes there to be a warm ocean current instead of a cold one by, and I'm going to abbreviate here to save some space, South America. When you have a change in the ocean currents, this can lead to a change in the moisture content of the atmosphere in those areas, and we've talked about over and over again how the temperature of the water and the moisture content above in the atmosphere can change what kind of storms you get, or the amount or the severity of the storms that you get. So El Nino can bring storms to places that don't usually have storms, and it can also cause the opposite. So you'll hear on the news that they're talking about how this is an El Nino year. They're expecting that our winter may be warmer and milder in terms of snowfall than would otherwise be the case. The last thing on our short-term climate change list, we're going to see if we can tuck this one in right down here. This one has also been in the news somewhat recently. This is solar activity. Solar activity has to do with the number of sunspots. Again, that's something we'll learn about a little more in the next chapter. It also has to do with the amount of solar storms, or storms of solar particles that we get from the sun. Just this past week, there was a solar storm where you could see the northern lights as far south as Chicago, and there were some pretty amazing pictures taken from around Lake Michigan up there this week. Solar activity in this sense refers to the number of sunspots, and the number of sunspots corresponds to how active our sun is. The more sunspots, the more active the sun, the more solar storms, the more northern lights. And when you take those things away, when the sun becomes less active and there are fewer sunspots, that cycle of fewer sunspots corresponds to times of colder weather, colder climate. And this typically happens about once every 11 to 12 years. That's how often the sun cycles through from a maximum number of sunspots to a minimum number. So if you're wanting to see the northern lights, wait about another 10 to 11 years to go see the northern lights in places like Alaska and Iceland, because we are headed out of our solar maximum right now. We're headed into a minimum. So fewer sunspots usually corresponds to a time of colder weather, a time of colder climate. One in particular we're going to learn about this week was a kind of a standout in this category, and it goes by the name of Maurice Minimum. Maurice was the scientist that first came up with this connection between sunspots and climate, so they named this idea after him. Maurice Minimum would be few sunspots, very few sunspots, and this was a time in history, in the 1600s, I believe, during which it got very, very cold because there were very few sunspots. 1645 to 1716, there were very, very few sunspots, and it was called Maurice Minimum, or the Little Ice Age. And supposedly during this time period in history, there were people in London ice skating on the river in June. And London has a kind of similar climate to what we have here. We would not expect to be ice skating in June. So that's how cold the solar activity can make it, or how much it can change our climate. So we are headed into a time of fewer sunspots, probably not quite as severe as Maurice Minimum. Although if you keep up on the science news, there was an article that circulated a few months ago that said we might be going into a little ice age. And then, of course, as happens often with the press, they came out later and said, no, our research doesn't actually mean that. We're not going into a little ice age. So we have 4 things in our short-term climate change list. We have seasons, which we are all pretty familiar with, caused by the tilt of the axis. We have volcanic activity. Dust and ash can block the heat from the sun. We have El Nino, a reverse in ocean currents, which can change the climate by changing the weather. And we have solar activity. The number of sunspots is related to the weather and the climate that we have. Next, we're going to switch gears and do long-term climate changes. So things that can cause natural climate change over a very long period of time. And the things that we'll put on this side, things that take tens of thousands of years at the very least, and up to much longer time periods than that. So long-term, put that over here, long-term climate changes. First one we're going to put on this list is probably the one that you're most familiar with, and that will be ice ages. Probably you've learned about ice ages before, somewhere in elementary school at the very least. Maybe you've seen the movie. Ice ages are periods of course, colder climate, and they would be cold enough that whatever glaciers are currently on the planet would advance, and that means they get bigger. They come further south. During the last ice age, which ended about 10,000 years ago, glaciers came as far south as Indiana. And if you drive across the prairie in Illinois and Indiana and you happen to look out at the car window and you see giant boulders sitting like in the middle of a field and they just don't seem to belong there, chances are pretty good they were deposited by a glacier. In between ice ages, which is what we are in right now, we have what are called between glaciers, intervals. Interglacial intervals. That's a mouthful to say that those are the times when the climate is a little bit warmer, as it is now, and whatever glaciers we have on the planet are retreating. In other words, they are getting smaller, they are shrinking, and only the most northern points or southern points on our planet still have those glaciers remaining. These are probably the shortest of the things on this list, tens of thousands of years. The other things on this list take much, much longer to cycle through, from 40,000 years up to 100,000 years. Other things that can change Earth's climate over the long term. One of them, kind of like we talked about on the first side, Earth's tilt causes our seasons. And Earth's tilt right now is 23.5 degrees. Our poles are tilted 23.5 degrees. And there's really good pictures of this in your book, but Earth's axis looks approximately like that. This causes our seasons. So if you change the amount of degrees that Earth's axis is tilted, that would change our seasons. So change in tilt would equal a change in seasons. And this could either make it warmer or colder depending on if you're tilting it more or tilting it less. But if you change the tilt, which the Earth actually has a tendency to do, about every 41,000 years, it ranges from 22.1 degrees to 24.5 degrees. The more or the less the Earth is tilted on its axis, that's going to change the seasons and make it either warmer or colder. Another thing that can change the seasons one other note that we're going to put here next to this one is just a reminder that when we're talking about seasons, the northern and the southern hemispheres, I'm going to try to abbreviate here and save some space, are opposite each other. So when we're having summer, the southern hemisphere is having winter and vice versa. Those things are not changing with the tilt, but again, it's just a little reminder that we are opposite of the southern hemisphere. We've got two other things to put on here in the long-term category. One of them is the shape of Earth's orbit. So we'll put that one right here. Earth's orbit shape. Just like the degree of the tilt can change, the shape of Earth's orbit can also change. And this is on about 100,000 year cycle. So it doesn't happen very often, certainly not going to happen in our lifetime. But the Earth's orbit can change its shape from more elliptical to more circular. So an ellipse is like an oval. And we have the Earth going around the sun, so we'll put the sun in here, kind of. Or it could be more like a circle. And then it would look more like this, and we'd be going around the sun in the center. If the shape is more elliptical, that means that the Earth moves closer to the sun for a larger portion of its path, and that makes it warmer. If the shape is more circular, then that means that the Earth is further away from the sun for most of its path, and that makes it colder. And just in case you can't see that, think about the Earth moving around the sun, especially this portion of the path, this portion of the path. It would be closer to the sun than, say, here, where it's a more even distance all the way around, but it's a further distance away. Okay, we've got one more thing to squish into this bottom corner here. Oh, my lines are going to have to cross. One more long-term climate change, and we'll just put it right down here. This one we will call Earth's Wobble. If you think about a spinning top, if you wind up a top or a gyroscope, something like that, and you let it go, it will spin pretty tightly and pretty consistently for a while. And then as it gets close to slowing down, it will start to wobble on its axis a little bit. And I'm not trying to say that the Earth is slowing down and it's going to fall over like a top, but it's that kind of idea that a spinning object may have its axis wobbling a little bit back and forth. So we'll put an explanation here. Earth wobbles on its axis as it spins. So there's your definition or your explanation of what Earth's wobble is. Just like a top kind of wobbles on its axis. And what this causes is eventually our axis will point to a different star than it does now. Point to a different star than it does now. Right now, our North Pole points towards the North Star. Most people know that. The North Star's name is Polaris. And right now, our Earth's northern axis points towards the North Star. But eventually, as the Earth's axis wobbles enough, it will point towards a different star, and that star's name is Vega. Again, there's a really good picture of this in your book. When that happens, and this is a very long-term climate change. This would be about 26,000 years in between one star and the other. But eventually, if it points to a different star, that is going to switch the direction of the tilt. And if you switch the direction of the tilt, then you also switch the seasons. So eventually, over a period of 26,000 years, you can switch the season that you normally associate with summer to winter and vice versa. So on this side, we have 5 different things that can cause long-term climate change. We have ice ages that are cold, interspersed with interglacial intervals when the planet warms up. We have the tilt, which we know causes the seasons. The amount of the tilt can change and change the seasons, how warm or how cold they are. We have the shape of Earth's orbit. If it's an ellipse, we're closer to the sun, we're warmer. If it's a circle, we're further away and we're colder. And we have Earth's wobble. Right now, the North Pole points to the North Star. Eventually, it will switch to a different star, and when that happens, we'll have an opposite tilt and we'll have opposite seasons. Okay, we have summed up all of the information in 14.3. I know it's a little bit crowded on here. Hopefully your paper's a little less crowded than mine. And hopefully this will help you study or help you keep this information organized as you are studying for the quiz this week.